Okay, let's look at the section 9.5 continued, right? So let's look at this theorem, right? We already showed that if f is a bijective function from a to b, then its inverse relation is also a function. So there's an inverse function, right? Now, on top of that, f inverse is a function. F inverse is going to be bijective as well, right? Let's try to show that, right? So start with, right? Assume that f is bijective, right? So that's given, right? 2. All right, so let's try to show that f inverse is 1 to 1. So let's start with f inverse of b1 is equal to f inverse of b2. Right, let's call that a. Right, that's given. Right, 3. Right, so let's rewrite that. So since f inverse, so we're gonna let's say f inverse goes from b1 to a, which means that f will go from a to b1, right? At the same time, f of a will go to b2, right? So from line 2, right? Line 4, right? Since f is a function, so f of a is a single value, so f of a is b1 and b2 at the same time, which means that the b1 and b2 must be the same. So this tells you that the b1 is equal to b2, right? So this comes from the fact that the f is a function, but f is bijective, which included its f is a function. All right, so we have that. So therefore, this will establish that f inverse is indeed a 1 to 1. Right? So let's try to show that f inverse is onto as well. So line number 6 up here. So I'm going to say choose any element a in A. Right? So that's given. Right? 7. All right. So there exists some b in B such that f of a is equal to b. All right, since f is a function, so line 1. All right, then I can rewrite that as 8. There exists b in B such that the f inverse of b is equal to a. Right, so that comes from 7. Right, so this will establish that f inverse is onto, so it's 9. Right, therefore f inverse is on 2. Right, so this comes from let's say 6 and 8. Right, then combining those two, 1 to 1 and onto, we know that f inverse is bijective. Right, so this comes from combining line 5 and line 9. Right, so if original function is bijective, then f inverse is a function, and moreover it is also bijective. Right, so we can actually reverse this implication. since by you can do a symmetric argument because f is the inverse of f inverse, so it goes that way as well. All right, that's it. I hope that this was clear.